Hello everyone, in this tutorial and in the next couple of tutorials we are going to see how to integrate AWS services in Mule4. Particularly in this one we are starting with automating writing continuously coming data to S3 and also reading data from S3 using Mule4. So I have S3 here and let me create a bucket name. Let me call it maybe fish MuleSoft. The rest I can accept. The default is for this tutorial purpose. So create bucket. So I have this bucket. It doesn't have any data. Let's see if we can connect to this bucket from Mule4, and then we are going to upload data to here and see if we can list the objects that we have in this bucket. And then after that we are going to generate data every regular intervals and use Mule4 to upload it to S3. And finally we are going to see how to read data from S3, how to submit a request that gives data from S3. So Anypoint Studio is open here. The first thing is I have to add Amazon S3 module. So if it is not here, I go to search. I click this search in Exchange button. So when I click here, I get this. Then I type here Amazon. There are different Amazon connectors here, as you can see, RDS, DynamoDB, S3, and others. So I need S3 for now. In the other tutorials, we are going to see how to integrate Mule4 with other AWS services, including Redshift, RDS, DynamoDB, SNS, and so on. So now let's see with S3. So click add and finish. Now the module will be imported. So I have the S3 module here and the different operations here. So the first thing, let's connect to S3 and get the number of objects we have in S3. So first thing, we drag and drop a listener because we want to submit a request from Postman or from Arc that gives us the number of objects in the S3 location. So configuration, I will accept this default configuration with localhost and port 8081. Click OK. Okay, and the path, let's call it object counters. Let's put this underscore. Okay, so save this. Now let's just connect to S3. So we have here, and let's look for list objects. List objects is here. Drag and drop it here. So now we connect to S3. The connector configuration is here. We have to specify here the access key and secret access key and the region. Now it asks us for bucket name here. The bucket name we created is fish MuleSoft. So I can go here and type fish MuleSoft. I think that's the only thing I need. Now let's add a logger and see what this returns. Always it is good to see the payload so that we can perform the appropriate transformation. So I will add a breakpoint here and run this in debug mode. And until this deploys, let's go to Arc, and here I'm going to submit a request. So what was the path here under the listener? It is object counters. Okay, so object counters, let's wait until it deploys, and once it deploys we are going to submit it. So go to the console here, and it is almost done, I guess. So as you can see, this has deployed successfully. Now let's go here and submit a request. So I have added a breakpoint here as the logger, so it will stop here. That means once I submit this request, let's submit it. Now go to Endpoint Studio and see what the payload looks like. So here I see the payload is here. What do we have here? Okay, it is of size 0 because we are trying to get the list of objects, and there is no object in that S3 location, and this makes sense because we don't have anything here. So for test purposes, let's just upload some data. So I have some Python code here that generates random data, and what it generates is 10 rows with these columns here. So it is just random data. So let me generate a couple of data files. So this is my data location. It is going to put it in here. So let's write a couple of data files. So if you go here, it has written only already 4 or 5 data files. So if I open this and show you, so it is comma separated and it has the column shown. So let me stop that Python code. We'll come to that later. So stop this. Now the data that I generated, I can upload it to S3 and see if we can get the number of objects that we have in the S3 location using MuleSoft. So upload data files, just uploading data files here, tutorials, S3 data. I have these data files, upload them, upload. Okay, so now they have been uploaded. Then here I can click next and resubmit the request again and see if now if it shows non-zero number of data files. So come here and clear this and submit it. So now if we come to Endpoint Studio, the payload is here. It shows us there are 14 data files. So 0 to 13, and if we click first one, it tells us what the bucket name is, and the key is a file name here. So here we have the key. So to access the files, we have to use the key here. So okay, so now let's transform our payload so that we can get the number of data files. So how do we get the number of data files from here? Let me just click next processor here, yeah, let me submit it again. Let me submit another request again so that we can see, experiment here, how we can access the number of data files we have. So click payload here, okay, and we can see the payload. It is by default, it is in Java format. So let's transform it to JSON format so that we can print it in the browser, and it becomes also easier to get the count. So under the core module, we have this transform message. Bring it here before the logger and click it, and we want our data rather than our payload, rather than in Java, we want it to be JSON. So here payload, just save this. Now it will save the new changes, and then we are going to resubmit our request and see what the payload looks like. Okay, click next processor here. This one has not completed yet. Okay, let's submit another request again from here and see what the payload looks like. So as you see now, if you click the payload, there is an array, and the array has like the owner, different information, owner, and see key is here, the file name. So key, last modified date, and so on, size, and other kinds of information. So we just want the key here, and we can access the key by just using payload dot if we just do payload dot key, it gives us all the keys, that is all the data files. And if we do size of, if the size of should give us the number of data, the number of objects that we have in the S3 location. So bring this here, and once we do this transformation, then what we can do here in the transformation actually is, rather than simply putting the payload, we can do size of the keys from the payload. So save this. Now we can remove, let's click the next processor here. Now we can click we can remove the debugger here, I mean the logger, since we have completed it. So let's click design perspective. So this one, it should give us the number of data files we have, the number of objects that we have in S3. So now we are going to check, we are going to upload more data to that location and see if it gives an correct number of data files. Okay, so come here, go to Arc and submit another request. So it tells us there are, so the response is 200. That means it worked fine, and the number of data files it shows 14. Now let's generate more data files and upload them. So I will generate every second, or even I can comment this out. So let me load the packages first and generate a couple of data files. So as you can see, it is generating more data files. Okay, so we are going to upload these ones. This is enough for now. Stop the data generation on the Python side, and let's go and upload them. So go to S3 and S3 upload, add files. Some of them have been uploaded already. The rest we are going to upload now. So if we click upload, maybe it will overwrite them. Okay, so now it shows here we have 36 now the total number of data files is 36. We can also check it here. How many do we have? 36. As you can see on the bottom left here, we have 36 data files and we uploaded them to S3. So now we can send another request and it should return 36. Yep, so it returns 36. We can also remove some of them. Let's come here and let's just delete some of them, and so action delete. So I have to type here permanently delete. Okay, so if we come here, okay, so how many do we have now? We have 28. Now if we submit our request again, it should give us 28. Okay, so this is this is how we can, so in this so far what we saw is bringing in the module from Exchange. So if you don't have the module, AWS S3 module, you can bring it from Exchange by just searching here Amazon, and you get the different connectors for Amazon. So that's how we brought the S3 connector. Then we dragged and dropped a listener, and we are first experimenting if we can successfully connect to S3 and get the count of the objects in S3. So we use the list objects, and since the payload in this, the message that gets returned from this list objects is in Java format, we changed it to changed it to JSON, and actually we are getting just a number of data files, and we can do that by using payload double.key. So when we use size of payload double.key, it gives us the number of data files in that location. So next, let's see how we can automate uploading data to S3, especially when we have data that is coming regularly every some intervals. It could be every hour or every day, at some interval t. How can we schedule Anypoint Studio to upload data to S3? So let me stop this project, or I can even just add it here. So what I can do is under, let me rename this. Actually, it should not be RDS, it should be I have this project. Let me delete this one. And rename this project to S3. Call it S3. Okay, now let's create another flow, and that flow it is going to read data. It is going to read, okay, this one also refactor list objects. So this is what we saw. Now let's add another, right click here and go to Mule, and I guess it is here. We have to click here and go to Mule. Go to here, go to new and add Mule configuration file. Now let's call this upload continuous data, or data coming at regular intervals. Upload many files. Let's just call this. So in here we go first to, so what we are going to do is let's remove this data files. We are going to generate data every some seconds to this location, and MuleSoft should upload the data to S3. So here we go. The first thing is we go to the file module, search for file module, and we have this one on new or updated file listener, and we connect it to our working directory. So it should check for data files if there are new data files in our working directory, which is in our case this one, and it should check, let's say it should check every 5 seconds, and after uploading it to S3, it should back it up to some location and delete it from the original location. So let's say move it to backup. Okay, so this is it, and here once, okay, so the data we are going to access it as CSV format. If we are going to save it as CSV format, if it is in other for data format, we can go here to MIME type and specify the data type that it is going to read. So here data type is okay, so specified here, I'm sorry, this one should be default, we don't need it. Go to MIME type, yeah, and the data is text CSV. As you can see, it supported different data types, so we are working with CSV, and the separator, we can specify what the separator is. In our case, yeah, by default let's make it comma, but it can be tab or something else also. Okay, now once we do like this, let's create a variable that gets the file name. So set variable, and let's call it file name, and click this fx to make it an expression. So its value should be attributes.filename, so that we can use this to save the data, to name the data when we dump it to S3. So but we don't need the let's see if we need the extension. So this is a file name. Okay, next we have, if we go to the Amazon S3 connector, we have create object here, drag and drop it here. The same way I have to specify the connection. It used, since it is in the same project, it used the previous configuration that I specified. I just need to add the bucket name, which is fish MuleSoft, and the key is the file name. So the file name, I can just make it, change this to an expression, and it should be vars.filename, and the value, the object content will be the upload, the payload, that means the file, the content of the data file. So if we do this now, yeah, first we have to transform our data to CSV format though, because we want to save it as CSV. So we have to add a transformer and go here to transform message and bring here and make, rather than Java, let's make this CSV. We want the payload to be in CSV format, so that CSV should be written, that data should be written to S3. Okay, so now let's go to S3 also and remove every data file we have here. Okay, permanent delete. So delete everything. Now we don't have any objectives here. Okay, so here now I will run this code, this Python code that it is going to generate data files for me and save them to here. Then MuleSoft should take the data from here and save it, write it, upload it to S3 at regular intervals, and also back the data up here in this location. So let me make this backup location also just empty. Okay, so the other thing is this one, we are going to generate data every 2 seconds, and if we go here, our listener here, it is every 5 seconds. So before it uploads them, there will be a couple of data files written to this location, to the data location, because it will generate every 2 seconds. So it will generate two to three data files. Then this application is going to upload the data files to S3, and the Python is going to keep generating more and more data, and MuleSoft should upload the data at regular intervals to S3. So we can schedule our data upload when we have data that will keep coming. We can schedule it like this. So I guess now I have another Python code here. This one, simple Python code, what it does is it connects to S3, to my S3 account using my credentials, and it is going to check the number of data files I have there. It will check every 5 seconds. So let me run this and show what it returns. It should return now 0 because I have deleted the data files that we have in S3. So what is it saying? Okay, the bucket name is not test fish, but rather fish MuleSoft. So run this, and now see the number of files in the bucket is 0. Even after 5 seconds also it is going to say the same thing because we are not uploading. So I will stop this and rerun it once I start uploading data. Okay, clear this. Okay, so here what we have done is we have this listener that checks if there is new data in that folder every 5 seconds, and it is going to, once it uploads them to S3, it is going to delete, back them up, and also back the data to a local folder, to the backup folder, and remove it from the original location. And here we just, this set variable, it helps us to create a variable that we can use to use as an object name when we create the object in S3. And the data that this on new or updated file is going to read, the payload is in Java format, so we changed it to CSV since we want to write it in CSV format. And here we connected in the create object, we connected to S3, and we specified the bucket, and the key is dynamic in this case rather than just a single value, because we have multiple data files that is why we are making it vars.filename, and the content of the object is simply the payload. So let me run this, and once that deploys, we are going to start generating data files here and saving to our folder. Okay, so go to the console here. Let's go start generating data every 2 seconds. So just click here, run all. So if I go here now to my data location, see it generated 2 data files, and MuleSoft is taking it and it should be saving it to S3. As you can see here, it is working fine. There are no errors. So we see data coming in continuously, and after some seconds it gets removed from our working directory. And if you go to our backup location, the number of data files should be increasing. And if you go to S3 also, now if we refresh this, we should see more data files loading. Here you see we have this many data files. We can also run this code that checks the number of data files in that location every 5 seconds. So we have one code that generates data, one Python code that generates sample data, another one, and the Mule it uploads the data files to S3, and this part of the Python code it is checking how many objects or files in this case we have in our bucket. So you see the number of objects is increasing, so we can schedule it like this, and according to the schedule it can trigger and upload our data to S3. So basically understanding the transformation, setting a variable here to use it as an object name in S3, and also doing the appropriate transformation are the main things that we saw in this tutorial. This is enough for this video. In the next tutorial, in part 2, we are going to see how to read CSV, JSON, XML, and XLSX files in S3 using Mule.